Hello guys, this is the second part of lesson 1, observing chemical change. So this part we'll be talking about the signs or evidences of a chemical reaction. As you recall, chemical reactions are chemical changes. There are 5 main signs that a chemical reaction has taken place. What do we mean by sign? It's an evidence that the reaction has happened. Look at the first two. They could be combined together. Light released, temperature change. So these two are technically energy exchange. This one, production of a gas, we'll talk about it in a bit, formation of a precipitate, and color change. We will discuss these in details in the upcoming slides. Here you have a video you can watch in the slides of evidences of chemical changes. It's a really nice video. You can check some visuals and how reactions actually happen. So let's get started. Number 1, the first evidence is formation of a precipitate. First we need to define precipitate. We need to say what is a precipitate. A precipitate is a solid, okay, that is formed from 2 solutions mixed together. So we have 2 liquids, 2 solutions, we mix them together, a chemical reaction happens, and this solid is formed usually at the bottom of the reaction mixture, the bottom of the beaker. If you check here in this picture, you can see solid particles down at the bottom of the beaker or the flask. So this is your precipitate. Even though it may contain liquid, also a solution, I care about the solid particles that are formed down here. These are precipitate. You have an example, which is curdled milk. Okay. A typical example of formation of precipitate is a reaction called the Golden Rain reaction. If you check here, this is the chemical reaction, the formula, chemical equation. Potassium iodide and lead nitrate, both of these are solutions. They mix together, they give a new solution, a new compound, KNO3, which is soluble, and this one, lead iodide. This lead iodide is the solid that precipitates down in the reaction mixture. So the yellow solid, the precipitate, this is lead iodide. You have a video in the slides about the Golden Rain reaction. Watch it and check the precipitate, how is it formed. Second evidence, production of gas. The most famous example about this, you know it since you were kids, it's the reaction between vinegar and baking soda. You can trap the gas that's produced by using a balloon. Here in this slide we're using an example of yeast and sugar. Yeast and sugar fermentation. You will get bubbles here formed, which is evidence of formation of a gas, which is a sign of a chemical change. Now, why did we put the balloon here in this reaction? To trap the gas that is formed. When the balloon inflates, it's an evidence that a gas is being released from the reaction mixture and trapped in this balloon. So till now we have 2 signs. First is the precipitate, second is the formation of a gas. Third, color change. Color change in a chemical reaction is evidence that you have a new substance. Now you'd ask me, color change is physical by itself. Yes, color change is physical, like painting a door, for example. It's a physical change. But when we are studying reaction, the color change is a sign of a chemical reaction happening. So you're studying reactivity, and you have a reaction, it's an evidence that you have a new substance, like rotting of fruits, okay, or ripening. A rotting apple, ripening of banana. Number 4, change in energy. Like we discussed in class, breaking of bonds happens in the reactants, forming bonds happens in the products. Now, we have two types of reactions, exothermic and endothermic. In exothermic reactions, energy released in the products is greater than the energy required to break the bonds in the reactants. Examples: combustion reactions, anything that combusts or burns. You know that combustion needs oxygen. Burning wood, this is an example of an exothermic reaction. Now the other type, endothermic. In this type of reaction, the energy released is less than the energy required to break the bonds. Sorry about that. So the energy is absorbed from a nearby matter, so it needs energy to work, to happen. Another example of endothermic reactions, an endothermic reaction is photosynthesis. You know this from biology. Photosynthesis requires light energy to work, so energy is absorbed from a nearby matter. Light energy is absorbed from the sun in order for the reaction to work. It's an endothermic reaction. Here you have a picture that shows the difference between endothermic and exothermic. In endothermic, heat is required. In exothermic, heat is released. This is what you need to know here. These are examples, like we said, photosynthesis, this one. Light is taken or absorbed, so photosynthesis is an endothermic reaction. Frying an egg, you need energy to fry an egg, so energy is absorbed, it's endothermic. Exothermic, basically anything with explosion or release of heat. All of these are examples of exothermic reactions.